Hi friends, welcome back. So still we are seeing the DFT topic. So in that, let's say what we already done is a circular convolution between the two finite duration signals. Okay. Suppose uh, a signal x of n, which is 1, 2, 3, 4, and here n is equal to 4. That means it is a periodic signal. H of n is also 4, 3, 1. Let it is also periodic signal with a period of 4. Then how can we calculate y of n? So it is a convolution, but because these two are the periodic signals, we have to go for the circular convolution. X of n, circular convolution with h of n, with h of n. I told you how to do the circular convolution for this. Let's say 1, 2, 3, 4, 4, 3, 2, 1. So directly linear convolution we can do. After that, blockwise we have to take them and sum them. So what is this? 4, 8, 12, 3, 6, 9, 12. 1, 2, 3, 4, 2, 4, 6, 8. So by sum them 4, 11, this is a 19, 29, this is a 19 again, 10, 8. So in the circular convolution, how many number of samples actually? Number of samples in y of n is equal to maximum of n1, comma. That means number of samples in the n1 first signal, number of samples in the second. So here both are 4 only, maximum of 4, comma. That is, so we have to take up to this one, and after that we have to bring them back. So up to this we have to take, and whatever we are left with, take them here, and we have to add them blockwise. 19, 10, 8. So finally we are going to get 23, 21, and this is 21, right? 19, 8, not 21, it is 27, 29. So this is what y of n. Let's check it out whether it is true or not. 23, 21, 27, 20. Yes, this is the way we can do the circular convolution. And there is a method 2 also, that is a matrix multiplication method. I told you method 2, that is y of n is equal to, so matrix multiplication 1, 2, 3, 4. This is the matrix, and we are having a circular matrix. What is that? 4, 3, 1, 2. Next 2, 4, 3, 1, 1, 2, 4, 3, 3, 1, 2, 4. So this is the circular matrix. So if I multiply these two matrices, again we are going to get the same, what we can say, 23, 21, 27, 29. These are the samples what we are going to get. Clear or not? Take it. Let's take an example. If x of k is equal to 4 minus j2, 0, j2. Then find DFT of x of n. x of n. Okay. Listen here, x of n square. That means x of n multiplied with x of. So this is having DFT, which is x of k circular convolution, and there is a 1 by 4 because it is a 4-point DFT. 1 by 4 x of k circular convolution with x of x, because x of k is a periodic. Now, first find the circular convolution, then divided by 4. So, what is x of k circular convolution with x of k? This is what I am trying to find out now. So, I can directly go for 4 minus j2 0 j2. 4 minus j2 0 j2. So, if I take this 16 minus j8 0 j8 minus j8 minus 4 0 4 0 0 0 j8 4 0 minus 4. By adding that 16 minus j16 minus 4 j16 8 0 minus 4. So we require only 4 samples. The remaining samples we have to take them blockwise and add it. So if I add them, then what we are going to get? 8 0 minus. So finally it is going to be 24 minus j16 minus 8 j16. So this is what x of k circular convolution with x of k circular convolution with x. But what we require actually 1 by 4 x of k circular convolution with x of k. So what we are going to get? 1 by 4 24 minus j16 minus 8 j16. So how much is 6 minus j4 minus 2 j4. This is what we are going to get is the DFT of the x of n square. Clear? Take it. Circular convolution only, but remember 1 by 4 factor is there. If you see the signal replication property. What is that? Suppose if x of k, x of n having DFT, which is x of k, then what is the, suppose let's say if I take a signal which is in this way, x of n, and so on, x of n, like m times I have repeated, m times. For this signal, what is the DFT? That is m x of k by n, because it is having m times this sample, so it is also must have the m times the sample. Okay. Next, interpolation property, which is similar to this one. Interpolation property. What is the interpolation property? So if x of n having x of k is the DFT, x of n by m, then what is the DFT for this? If you take x of n by m, this is going to insert m minus n zeros. So finally the signal will be expanded. Then we have to expand this also. So So how it is going to be? Simply we have to take x of k, and so on, x of k. This is m time. We have to write it m time. Is that clear? Check it. Example: if x of n have dft x of k is equal to 8 minus j2 0 j2, then dft of first question, dft of x of n, x of n, x of n. So it is a signal replication property. So in the signal replication property, the thing what we are going to get dft is nothing but m x of k by m, where m is 3 x of k by. So what we have to do? 3 multiplied with x of k by 3. That means we have to insert two zeros in between the samples. 8 double 0 minus j2 double 0 0 double 0 j2. So this is what we are going to get. Now we have to multiply with 3. 24 0 0 minus j6 0 0 0 0 0 j6. Clear. Next, in the same way, second question, dft of x of n by n by 3, x of n by 3. From the interpolation property, it is having dft which is x of k, comma x of k, comma x of k, 3 times. So how it is? X of k, x of k. So we have to write 3 times. It's going to be a little bit big. 8 minus j2 0 j2. 8 minus j2 0 j2. 8 minus j2 0 j2. So this is what the answer is. Clear? Take it. Question number 2. x1 of n is equal to 1, 2, 3, 0. This is actually GATE 2015 question. Here is the arrow. x2 of n is equal to 1, 3, 2, 1. Here is the arrow. Find inverse dft of x3 of k is equal to x1 of k multiplied with x2 of k. Sorry. If x3 of k is x3 of n is x3 of n, then x3 of 2 is equal to dash. This is the question. x3 of 2 is equal to dash. See here, from this, what is x3 of n? So x1 of k multiplied with x2 of k. That means x3 of n is nothing but x1 of n circular convolution with x2 of n. That's it. So we have to do simply the circular convolution. In that we have to calculate what is the n is equal to 2 samples. Okay. So 1, 2, 3, 0, 2, 1, 3, 2. Circular convolution I am doing 1, 2, 3, 0, 3, 6, 9, 0, 2, 4, 6, 0, 1, 2, 3, 0, 1, 5. This is 11, 14, 8, 3. So we require only 4 samples because both are having 4 samples. So after 4 samples, we have to take it as blockwise and we have to add 8, 3, 0. If I add that, we are going to get 8, 9, 8, 11, 14. So this is what x3 of n. This is what x3 of n. So in that x3 of 2. So first sample is n is equal to 0, 1, 2. That is 11. 11 is the correct answer. Clear or not? Take it. Let's take next question. Question number 3. DFT of a vector A, B, C is alpha, beta, gamma, delta. Then consider the product. Then consider the product P, Q, R, S is equal to A, B, C, D, A, B, C, D, D, A, B, C, D, A, B, C, D. Then the DFT of vector P, Q, R, S is a scaled version of option alpha square, beta square, gamma square, delta square. Alpha, beta, gamma, delta. Root alpha, root beta, root gamma, root delta. Option, option, none. Listen here. What is PQRS actually? So let's say it is something like a y of n, which is the PQRS. So let x of n is equal to A, B, C, D, and x of k is equal to alpha, beta, gamma, delta. Alpha, beta, gamma, delta. So PQRF. If you observe carefully, this matrix multiplication is nothing but the circular convolution, because this matrix is nothing but a circulant matrix. So it is a circular convolution. So I can simply say x of n circular convolution with x of n circular convolution. So I want to calculate what is the DFT of y of n. So DFT of y of n is equal to x of k multiplied with x of k, which is x of k square. So what is x of k square? Already x of k is given alpha, beta, gamma, delta. For that, if it is a square, alpha square, beta square, gamma square, delta. So option A is correct. It is a scaled version, but scaling factor is 1 only. DFT of a sequence x of n is equal to 3, 2, 3, 4 is if x of k is equal to 12 j2 0 minus j. If x1 of k is DFT of x1 of n, where x1 of n is 3, 0, 0, 2, 0, 0, 3, 0, 0, 4, 0. Then the x1 of 8 by x1 of 11 modulus is dash. It is actually interpolation formula. So what is interpolation formula? If you observe carefully, x1 of n is nothing but x of n by 3, x of n by 3. So x1 of n, x of n having relation. So for this, what is the DFT? That is simply x of k. So let's call it as x1 of k, which is equal to x of k, x of k, x of k, 3 times. So what we are going to get? 12 j2 0 minus j. 12 j2 0 minus j. 12 j2 0 minus j. So this is what. Now they want to calculate x1 of 8 divided by x1 of 11. So here n is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 8, 9, 10, 11. So here, what is x1 of 8 by x1 of 11 modulus? x1 of 8, x1 of 8 is nothing but 12 by x1 of 11, that is minus j. So this is nothing but 6 is the answer. Now let's enter into FFT, fast Fourier transform. FF. So it is not a new it is not a new transform or something like that. It is a DFT only. It is a DFT only. But then why it is called as FFT? Because it is algorithm. It is a method to solve DFT. I hope understood. So it is not a new transform. It is exactly same as DFT only. But it is a algorithm to solve DFT in a faster manner. That's the only thing we can understand. So let's see. Suppose I can write this point, whatever I said. FFT is not a new transform. It is an algorithm used to solve endpoint DFT in a faster manner. Faster manner. How faster it is? Let's say, suppose if I take endpoint DFT and endpoint FF. This is a formula you have to remember. Endpoint FF. Suppose how many multiplications it requires? Multiplication. Then it is n square. N square multiplications are required to solve endpoint DFT. So we are not seeing how it is going to be n square. Just you can remember this. And whereas endpoint FFT, how many multiplications it will take is n by 2 log base 2 n. Log base 2. Next, how many additions are it required? It is n into n minus 1. Whereas endpoint FFT is taking n log n. So these many additions it requires. So that's the only thing you have to remember. Take it. And one butterfly diagram also. What is butterfly diagram? Suppose it is let's say 2-point DFT. I can say 2-point DFT. Here x of 0 is there, x of 1 is there. Then here we are going to get x of 0. What is x of 0? X of 0 plus x of 1. X of 0 plus x of 1. Whereas x of 1 is nothing but x of 0 minus x of 1. So this is a 2-point DFT butterfly diagram. So this is more than enough for us because to solve any question. So actually FFT is not a new algorithm. It is the same as DFT only. That means suppose if anything is given to you, find the FFT. So you have to find out the DFT only. You have to find the DFT. So if anything is given, so you can solve this very easily because so many people will go with the butterfly diagram. But in the examination, they cannot give you the question which is find the butterfly diagram. They will give you if it is possible. So this year, 2019, we're having one question which is butterfly diagram is given. They want to find out the some parameters inside that butterfly diagram. So how easily we can solve that question, we can understand. So these are the inputs what we require. So I am telling you to find FFT, we don't do anything. So because it is an algorithm, so I don't go into the algorithm. So the same whatever we have done in the DFT that we can do in the FFT to find FFT. So it is more like a divide and rule policy. That means if I want to get 8-point DFT, first that can be converted into 4-point DFT, 4-point DFT. Then that 4-point DFT can be converted into 2-point, 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 2-point. Like that, it can be divided, and this is going to be simpler. I hope you understood. So divide and rule. So that's what the FFT is about. Okay. First take down this, then the question what they have given, we can see that. Don't worry about the fast Fourier transform much because it is exactly same as DFT. It is same as DFT. It is algorithm. So if they want to calculate FFT, still you have to do the DFT. And we're having an easy method which is Fiddle matrix method. Let's see 2019 question which is given. So I'm not writing entire question. If you want, you can go through the question paper. Question number 5. So here W6 is nothing but e power minus j 2 pi by 6. It is a twiddle factor they have given, and it is given x of 0, x of 3, x of 1, x of 4, x of 2, x of 5. Okay. X of 1, a1, a2, a3. So finally, they want to calculate what is a1, a2, a3. So a1 is equal to minus 1, a2 is equal to w6, a3 is equal to w6 square. Option B. A1 is equal to 1, a2, a3. Okay, that's the question actually. Fine. A1, a2. So let's see. First, they have given x1 relation. Can you tell me what is x of k, which is summation n is equal to 0 to 5. Why? Because it is having w6, that means n is equal to 6 point dft. X of n w6 whole power k n, w6 whole power k. Now I want particularly x of 1. So k value is equal to 1. That is nothing but x of 0 w6 whole power 0 plus x of 1 w6 power 1, x of 2 w6 square, x of 3 w6 cube, x of 4 w6 4, x of 5 w6 power 5. So this is what it is. So this is the expression for x1. Okay. Now from this butterfly diagram, what is that? From butterfly diagram, first, what is x of 1? Let's say this is x of 0, this is x of 0 minus x of 3 into a1. So it is a1 into x of 0 minus x of 3. Next, plus a2 into a2 into what we are going to get? X of 1 minus x of 4. X of 1 minus x of 4 plus a3 into x of 2 minus x of 5. So this is what we got. Now if you observe carefully, a1 is nothing but x of 0 coefficient. So by comparing a1 is equal to w6 power 0, that is nothing but 1. What is a2? That is coefficient of x1. What is coefficient of x1? W6 power 1. What is A3? That is a coefficient of x2. That is nothing but W6 power. This is the answer. So what it is? Yeah, option C is the correct answer. Clear or not? So without doing anything, we can solve it in a easy manner. So with